Hello, good afternoon everyone. I'm Miss Kanchan and I would be dealing with one of the topic from organic chemistry, that is haloalkanes and haloarenes. But before that, we being a team of Greek classes would like to wish you all happy Dasera and let us have our session without wasting a bit of time. Okay. Let us know that organic chemistry as such in part 2 chemistry or in chemistry syllabus has more weightage, so you cannot ignore a bit of second also to spend more time on this. I know that most of the students find difficult this organic chemistry. The reason behind that are many organic reactions, how to memorize them, how to know what is the reaction, what is the product, and writing the reaction they find, writing the nomenclature they find it difficult, but it's my prime duty to make it more interesting and more reliable. Well, so let us know about what all things we are going to study in this chapter, haloalkanes, haloarenes. The name of the topic is haloalkanes and haloarenes. See students, when we say haloalkanes or haloarenes, that means they are actually halogen derivatives. They are halogen derivatives. Halogen derivatives meaning, we know that the formula or the general way to represent alkane is RH. Okay, so if RH, we can write this alkane as like this also. So now if one of the hydrogen of this alkane is replaced by halogen group, they are called as halogen derivatives, meaning they are the halogen derivatives of alkane. And when we say haloarenes, that means they are related with aromatic ring, benzene ring. So in case of benzene ring, if we know that this benzene ring, there are 6 carbons all around this benzene ring and if one of the hydrogen is replaced by halogen group normally denoted by X, where halogens like fluoride, chloride, bromide, iodide can be the halide which can be substituted to in place of hydrogen. So basically we are going to know haloalkanes and haloarenes in terms of aliphatic compounds and aromatic compounds. Okay, well, now coming to what all things we are going to know in this chapter is, first most point, we are going to understand their classification. We are also going to know about their nomenclature. We will know their physical and chemical properties. We would also be focusing on their preparation method. We will know that if the haloalkanes and haloarenes are available, then how can we use them to prepare different other compounds, so their reactions, and then at last we will know uses. So all these aspects we are going to know in this chapter one by one. This is general introduction I have given you about halogen derivatives. So in case of aliphatic compound, if we see, in case of aliphatic compound, this R group can be aliphatic, that means sp3 carbon, or it can be sp2 carbon, or it can be sp carbon. Based on that, the classification begins, and also there is possibility that this alkyl can be either fluoride, chloride, bromide or iodide. So accordingly the another class of haloalkanes we can have. And then we can also know depending on the number of halogen groups that are attached. Okay, so accordingly the classification will be. So let us study one by one. Now we will focus on their classification. The first most point in the classification we will have, that is based on the number of halogen groups that are present to the alkyl group. That means, suppose based on classification, first one, that is based on number of halogen group. Number of halogen atom. So let us say, for example, I know that this is methane, right? So there are 4 hydrogens attached to this carbon. Subsequently, each hydrogen can be replaced by halogen, let's say for example chlorine. If one chlorine is attached, then we can call this as chloromethane. If there are 2 chlorines attached, then it is dichloromethane. So the prefix di is used based on the number of, because there are 2 chlorines. So accordingly tri, tetra would be prefixes used with respect to the number of halogen group or chloro group attached. So dichloro, because there is 1 carbon, so it is methane. So dichloromethane. Now let us say for example I may have 3 carbons, and subsequent each carbon would be having halogen group attached to it. So over here now there are 3 chlorines attached. So and each of them, each carbon is having chlorine group. So I would first most job while writing the name, that means I need to number them. So there are 3 carbons and each of them having chloro group. So I would write this as 1, 2, 3, and there are all of them are chlorine only. So trichloro, and there are 3 carbons. So trichloropropane. And suppose if I have chlorine group attached to carbon all over, that means the entire valency of this carbon is satisfied by chlorine group instead of hydrogen, then it is called as carbon tetrachloride, or we can also say tetrachloromethane, commonly called as carbon tetrachloride. And we all are aware that the chloroform is one such chemical or one such organic compound which is used more often, more commonly, that is chloromethane. It is there are trichloromethane, where 3 hydrogens are substituted by chlorine group, and this one we call it as CHCl3, that is chloroform. Formula is CHCl3 and the common name is chloroform, or we can also call it as trichloromethane. Okay, so this is how the different, depending on the number of halogens we can have we can see here if there is only one chloro, so chloromethane. If there are two chlorines, so di will be the prefix used, and if there are three, then trichloro. But see that we must mention the positions of those chlorine attached to the carbon. So 1, 2, 3, and then we can see if there are 4 chlorine, then carbon tetrachloride. If there are 3 chlorine attached to the same carbon, example here chloroform CHCl3. So over here we can see that the number and alphabet is separated by hyphen, and if the alphabet and alphabet is there followed by alphabet only, it is written continuously with no space or with no capital letter or any hyphen or nothing should be given, but rather it should be written continuously. So these are some points which need to be understood while naming the organic compound, but right now we are focusing on classification based on number of halogen atoms. Okay, now the next class begins, that means classification based on type of carbon atom to which halogen is attached. That means there is possibility that the carbon to which the halogen is attached can be sp2, can be sp3, that means single bonded, or it can be, let's say, so based on type of carbon atom, based on type of carbon atom. So in this class, let us say, for example, and chlorine is over here. So now in this compound, everywhere there is carbon-carbon single bond. Okay, that means this is saturated carbon, or this carbon is actually sp3 hybridized. The type of hybridization is sp3 because everywhere it is double bond. Okay, so now let us know the position of the chlorine. It is present on carbon number 2, right? So it is 2-chlorobutane. 2-chlorobutane, where chlorine is attached to sp3 carbon, which is single bonded carbon. Okay, now I'll take the same example and I'll just slightly modify. The double bond is over here, and that same carbon is having chlorine. Okay, rest all, I assume that you all are aware how to satisfy the valency of the carbon. Are you? Okay. Alright. In case of any difficulty, please feel free to ask. You can interrupt me, you can stop me, you can tell me to revise, and provided you can also put a message. See that you understand this thoroughly. You never know, the question can be framed on classification or nomenclature, or sometimes in MCQs the question can be there. So here we can see the carbon-carbon double bonded system is having chloro group attached to it. So this carbon is actually now sp2 hybridized, meaning it is having double bond, planar system. Okay, I hope you all are aware that in 11th standard chemical bonding chapter, where you have thoroughly understood sp3, sp2 and sp hybridization. sp3 is the one where tetrahedral system or tetrahedral is the geometry, and where carbon-carbon is single bonded and it is saturated system. Whereas when we say sp2, it is a planar, trigonal. Planar is the structure, geometry takes, and it is sp2 because there is one s and two p orbitals are hybridized or overlapped, forming trigonal planar geometry. So now again same thing, that means we need to label the carbons, number the carbons. It is carbon number 2 that is having double bond to which the chloro group is attached. So it is 2-chloro. Now we should also mention the position of the double bond. The smallest number, that is carbon 2, is having double bond to which the chlorine is attached. So it is 2-chlorobute because there are 4 carbons. So it is 2-chlorobute, 2-ene. I hope you are understanding this. Okay. So this is 2-chlorobute, 2-ene. We have mentioned the position of the double bond. We have mentioned the position of substituent also. Okay. Now after that we will also see, suppose if there is any triple bonded system, okay, and to which the chlorine is attached. Okay. So we can have here this example where triple bonded system, that is carbon, is having chloro group there, and there are total 3 carbons. First most carbon is having triple bond, yes, you can see that, and also the same carbon is having chloro group. You cannot put this carbon at this, because otherwise the carbon would have 5 bonds, which is not possible. Okay, that's the reason we must take into account that carbon valency cannot be disturbed. Please check that everywhere carbon should have tetravalent nature, meaning 4 bonds. Okay, so here there are 3 carbons to which chloro group is attached. So this is carbon number 1, 2 and 3. First carbon is having triple bond, and that same carbon is having chloro group. So it is chloropropine. It is chloropropine. Okay. Now, you might wonder why I have not mentioned the number, why I have not introduced the number of the substituent or number of triple bond. Okay. See now, here I had put the number, but here I did not. The reason behind that is, the first most carbon itself is triple bonded. The first most carbon is having substituent. So it is by default understood when you don't put the number that it is first carbon having substituent and triple bonded system. That is why you are not introducing the number there. One more thing, here in this system, it was the middle carbon that was having such unsaturated system, that means double bond was introduced, and also the substituent was present in the middle carbon. That is why you needed to mention the position of both, that is functional group. Over here functional group is alkene, over here functional group is alkyne. Okay, we must mention the position of double bond along with the position of the substituent. So otherwise here, because it is the first carbon that was having a substituent, so it was not needed to mention the number. So it can simply, we can write here as chloropropine is the correct nomenclature for this compound. But please make a note, one important point again and again I am reiterating, that is tetravalency of the carbon should be maintained. Now the next one, this is based on the type of carbon. So here sp3 carbon having chloro group, sp2 carbon having chloro group, and sp carbon. So over here it is triple bonded. So this carbon is actually sp hybridized. Okay. Well, I hope it is clear. Any doubt, please? Okay, good. Thank you. Now coming to next method of classification, we can have there are two slightly a bit different kinds of classification we can have, that is about special types of haloalkanes we can have. Now we all are aware say, I would write C. This is also again a kind of classification, some special type of compounds. Some special types. Let's say for example, I have saturated, unsaturated system where carbon-carbon double bond is present. Alright. Just before a while, we have already seen this example. Look at this carbon, it is sp2 hybridized. Alright, this one is sp2 hybridized, and this carbon would have chlorine, that is one possibility, or perhaps the neighboring carbon can have chlorine group attached to it. So these are the two possible ways I am writing. That means where chlorine here sp2 hybridized, but that is not the one bearing chlorine. Rather, the neighboring carbon is having chlorine attached to it. So these are the two ways in which the chlorine can be bonded to unsaturated system, that is double bonded system. So over here again let us satisfy the valency of carbon, go on putting the hydrogens. This is how it's going to be. Now after that, so here in this case, because the double bonded carbon itself is having chlorine attached to it, we would call this system as vinyl chloride. This is a class, it is not the name of the compound. Make a note. This is simply a class of compound, but it is not nomenclature. It is vinyl chloride. Whereas the neighboring carbon is having chlorine group. So over here, this one we call it as allyl chloride. This is allyl chloride. Okay, so this is vinyl chloride and this is allyl chloride. Okay, so in case of vinyl chloride, what do we see? That the chlorine is bonded to unsaturated carbon itself. Double bonded carbon having chlorine bonded to it. Whereas in case of allyl, it is neighboring carbon or it is indirectly bonded carbon showing chlorine group. Meaning it is double bonded carbon but not that itself, but the neighboring carbon, just the immediate next carbon is having chloro group attached, that is called as allyl. Okay, these are some of the specific types of haloalkanes we should be aware of. Then we can also have in case of aromatic system. Okay, now coming to aromatic class, so that is haloarenes. Okay, so in this haloarenes we know that this is the benzene ring, correct, and all of them are the hydrogens attached to it. Okay, and there is also possibility that the halogen group might be the part of the benzene nucleus, aromatic nucleus. So we would call them as nuclear halogen compounds, and then other class that is substituted or side chain aromatic compounds. Okay, side chain haloarenes, whereas this one could be nuclear, see like this. So this could be, now this is part of the ring itself, whereas this one is as a substituent. That means what? Substituent which can be bonded to the aromatic ring, but not that is part of the ring, but it is attached to the side chain as a side branch. Meaning this could be through one carbon. Okay, through one carbon. This act as a side chain and this one directly attached to halogen. So over here this one we call it as chlorobenzene and this one we call it as benzyl chloride. Benzyl chloride. Or we can also say this one as one carbon which is having chlorine group, which is having phenyl group. So phenyl chloromethane. Okay, chloro. Now aliphatic, we know that we should number them aliphatically. So alphabetically. So this would be chlorophenyl methane. Chlorophenyl methane. So this one is actually a common name and this one is IUPAC name. Okay, chlorobenzene itself becomes the this thing common name and also IUPAC name. Based on benzene ring, this type chlorobenzene comes under nuclear haloarenes, whereas this one becomes side chain haloarenes. I hope this is clear to you. Is board visible? Legible? Okay, good. Thank you. Let's go to the next one. So this is all about classification. One more thing, we can have like I hope you all are aware about what is primary, secondary and tertiary carbon. Okay, so that is also another class of haloalkanes we can have, where the halogen could be attached to primary carbon, secondary carbon or tertiary carbon. So there can be primary, secondary, tertiary haloalkanes. Nature of, this is I would say D type. Nature of carbon atom. Nature of carbon atom, that can be primary, secondary, tertiary. Tertiary, primary, secondary, tertiary. So over here in case of primary, there will be only one neighboring carbon, meaning CH3, CH2, Br. Okay, so this is primary carbon, 1 degree carbon. Whereas in case of secondary, there will be two neighboring carbons to which the bromine is attached. So this is secondary carbon to which bromine is attached. So this one is 2-bromopropane, or we can also call it as isopropyl bromide, 2-bromopropane, and this one is bromoethane. Now tertiary, this one would be the one which is having three adjacent carbon, neighboring carbons to which the bromine is attached. So that is 3-degree carbon. So here this one we call it as tertiary butyl bromide, or we can also call it as 2-bromo-2-methyl propane. 2-bromo-2-methyl propane. Okay, so based on primary, secondary, tertiary, we can have this kind of classification of haloalkanes. I hope it is clear to you. There is also one more now, the next, I mean it doesn't come under this, but still I can tell you about the compounds containing, as I have told you. Suppose, can you identify if I have a system, whether it is allylic or vinylic? Please try to identify. Yes. So here this one is, yes, correct. This is vinyl. And what about this? Oh yes, that's right. So that means even though there is cyclic system and position of the halogen, where whether it is attached directly to the double bond or indirectly, accordingly the class we have seen, that is vinyl and allyl. So obviously this one is allyl and this one is vinyl. Very good, that's right, correct. Now can you identify whether this one is a, this one, whether it is nuclear or as a side chain? It is nuclear, it is part of the ring. Bromine is directly attached to the ring, so this is nuclear, it is not side chain. Although it is not haloarine, but it is acting as the nuclear, which is part of the ring, but it is not isolated, it is not bonded through one of the carbon. I mean, the cyclic system is not directly attached to bromine, but rather it is having indirectly bonded through one carbon. So it is nuclear system. Now coming to next, this is all about the classification. Let's go further about nomenclature. Some of the compound you all have thoroughly studied about this nomenclature in grade 11. So randomly, suddenly few compounds I will take their common name and IUPAC name as a practice, but before I directly jump on to examples, but we can have a quick recap of the rules for nomenclature. So what are the rules? Yes, the first most point is to identify the longest chain. That's right, correct. Okay, so first most point is we should know the longest chain, correct. And after that, but one thing I want to tell you that this one, we should know the different groups, like CH3, CH2, CH2. These are the groups which are acting as a substituent. So this one, now look at this. There is 3 carbon system and the last carbon is part of the, it is acting as a substituent. Okay, so we use N prefix for such kind of substituent. And suppose if I have a substituent where the middle carbon is the part of the longest chain. Okay, this middle carbon. So and it is having 3 carbon. So I would use the prefix iso. I would use the prefix iso. And suppose if I have, this is also CH3, this is also CH3, and this is also CH3, to which this could be the part of the ring, then this can be, we can call it as tertiary. Okay, and suppose there is possibility that you might have the system where quaternary carbon, this is quaternary carbon, okay, and this one is having halogen attached to it, or which could be the part of the ring. Okay, then this would be neo. This can be act as a neo. Okay, so now coming to some of the examples of the nomenclature, let's have. Okay, and then here CH3, here Cl, and this one is having here, there is CH3. Okay, so and let's have one more example. Again it is a 7 carbon system, and then the third carbon, and this one is having bromine. Here there is methyl group attached. This carbon is having methyl group. So this is one of the system. Let us know how to write down the nomenclature for this carbon system. Okay, so now the first most point is how to start numbering. Okay, we can know the longest chain 1, 2, 3, 4, 5, 6, 7. So this is 7 carbon, that means heptane system. Okay, heptane system. And then we should also see that it from here, from left to right, it is carbon number 2 having methyl group. Even while beginning from right to left, it is carbon number 2 that is showing substituent. Okay, but the which substituent should be given the priority in this is chloro, being alphabetically C letter comes first, so that goes the highest priority order. So the numbering would begin from here. and then the naming will be 2-chloro. Now look, carbon number 6 and carbon number 3, both of them are having same substituent, that is methyl. Okay, so we can use as dimethyl, but provided let us mention their numbers. It is 3 and 6 carbon that are having methyl group, so it is 3,6 dimethyl, and the longest chain, that is heptane, so dimethyl heptane. So this is the correct nomenclature for this carbon. Now coming to next, over here in this case we will see that 1 2 3 4 5 6 7. So from here the bromine is the first most substituent we see at carbon number 2, so obviously the numbering would begin from here. Okay, so it will be 2 bromo 4, 5 dimethyl heptane. Okay, now the next one, let us have few more compounds as a practice. I have one system, let's say here there is Cl, here all of them are CH3. Now if you remember, just now I told you this one is neo, but that comes in common name. Okay, this is like neopentyl chloride, which is common name. Okay, I will write here neopentyl chloride. This is actually common name, but its IUPAC name would be IUPAC name. Now let us know this one, carbon number 2, 1 2 3 in there are 3 carbons in one line, so it is propane system. It is chloropropane, but at carbon number 2 you have 2 methyl groups, so it is 2, 2 dimethyl, now 2, 2 dimethyl. Then at carbon number 1 we have chloro group, but then alphabetically look at this M letter and look at this C letter, so C comes first, so we need to mention this 1 chloro 2, 2 dimethyl propane. Okay, so first is, let us identify the substituents and then put them in alphabetical order irrespective of what is the number it will bear. So at carbon number 1 it is chloro, so 1 chloro 2, 2 dimethyl propane. So this is the nomenclature for some of the compounds I have shown you. Now let's say what will be the nomenclature for this compound. You are going to try by yourself. Yes, let's work upon some of the examples as a practice. CI3CH3. Yes, tell me. Try by yourself. No problem. Common name or IUPAC name, however. Yes, you can. Okay, I'll give you time. Okay. Yeah. Yes, tell me. Correct. So over here there are 3 iodine groups attached to carbon number 1. So it is triiodoethane. That's right. Okay, but at the same time we should see that it's carbon number 1 which is having iodine group, so we can write here as 1, 1, 1 triiodoethane. Okay, so let us work upon one cyclic system, try out. Now after that, here there is fluorine, we have chlorine groups attached here. Okay, so alphabetically C letter comes first, alright, and fluorine will be later, but then numbering would begin from the chlorine. Okay, smallest numbering should go to substituent, that is the rule. So it is chlorine which will have carbon number 1, but there are 2 chlorine attached. Okay, so it will be 1 comma 1 dichloro 2 fluoro. Now this entire system is cyclohexane. So it is cyclohexane. Cyclohexane. I hope it is clear to you. Now let us try out some other. If suppose there are more than one halogen group, okay, let us look for nomenclature of subsystem also. I CH2 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 CH2I. Yes, what will be the nomenclature for this? Yes, it is carbon number 1, 2, 3, 4. That means 1 and 4, both these carbons are having same iodine as a substituent, so it is diiodo. But at the same time we see that it is carbon number 1 and 4 that is having iodine. So 1 comma 4 diiodo, not to miss out any letter. Write that Di for di and iodo IODO. So do not miss out any letter even if it is repeating. Okay, so diiodobutane. Diiodobutane. Hope it is clear. Okay, now let us work upon some of the okay, let's say CH3 CH double bond CH CH2Br. Now yes, tell me, first most point you need to tell me which type of haloalkane it is. Yes, see, look at this. Yes, correct. It is allyne. Very good, very good. Okay. Now, how many carbons in all it is covering? There are 4 carbons. Okay, that's right. Where, what is the position of the bromine will be now? Carbon number 1. Okay, that's right. And what about double bond? It will be carbon number 2. Okay, fine. So, let us work upon their nomenclature. So, it will be 1 bromo 1 bromo. Now there it is bromine, there are 4 carbons, so butane system, but it is butane, but-2-ene. So 1 bromo but-2-ene. Okay. Yes, anyone? What? 2 butane? No. You have learned how to introduce the number in case of unsaturated system. You cannot write this one as 1 bromo 2 butene. No, you need to write this butene. We know that if double bonded system is there, E and E will be the ending. Okay, so it is, and there are 4 carbons, so it is but. So butene, but then you need to introduce the number over here. That means it will be but-2-ene. Okay, and as I have already told you that the number and alphabet will be separated by hyphen. Okay, so it will be but-2-ene. Alright, so the name is 1-bromobute-2-ene. Okay, so this is all about some of the aliphatic compounds I have taken. Now coming to some of the aromatic compounds. Okay, so let us work upon some of the aromatic compounds nomenclature, where aromatic system can have halogen directly bonded to the ring, or like it is part of the benzene nucleus, or it can be the as a side chain. Okay, both ways we will work out. So some of the examples I would show you how to name, and few more I would give you as a practice. Okay, so let's work upon that. Yes, so here I have an aromatic system, and let us say bromine. So this is obviously bromobenzene. Okay. Now, if the same aromatic ring is having bromine over here and bromine to the neighboring carbon as well, then in that case, we all know very well that in case of aromatic system, if there are two substituents at adjacent position, that is carbon number 1 and 2 or carbon number 1 and 3 or 1 and 4, accordingly it will take ortho position, it will be meta position, and this will be para position. Okay, so over here bromine is attached to adjacent carbon, that means this ortho will be always adjacent. Meta is alternate, and oh, it is not visible. Okay, I will write here. Okay, I will rewrite, don't worry, we will have thorough revision. Yes, so I'll write here, hope it is visible to you. Now see, if there is aromatic system and the substituents, okay, substituents are carbon number 1 and 2 or carbon number 1 and 3 or carbon number 1 and 4, it is for disubstituted. All right, this rules applies for disubstituted derivatives. Okay, so over here suppose if I have two halogens to the neighboring carbon, then that will be like ortho, okay, which we denote by O later, and for hint I would write here in the bracket adjacent, and when it is 1 3 it is meta, that means alternate, it is the alternate carbon that would show substituent. And if there is end on, that is what do you say, diagonal, okay, or I would say that one as end to end, okay, then that is like para, it would be shown as P later, para. Okay, so now over here the substituents are at the neighboring carbon, so it will be ortho dibromobenzene, or we may also say as 1,2 dibromobenzene. Yes, 1 2 okay, see the basic here is a doubt that when to use this ortho or para meta prefixes and when to use the numbering. See, numbering is used specifically when we write down the nomenclature via IUPAC system, okay, otherwise common name when you want to write down, you can use this prefixes ortho meta para, that means ortho dibromobenzene. And especially for IUPAC, follow the number system only, not to use prefixes, because there is possibility that not two but more than that can also be the substituent. So that's why it's better to use the number system while writing the nomenclature for halogens, aromatic compounds, substituted compounds. Okay, now same thing if I have, let's say here bromine, and the bromine is at this position, then in this case it will be para dibromobenzene, or we may also say this one as one 4 dibromobenzene. Now this one would be yes, all positions are identical, correct, all positions are identical. It is not that I am showing here that means these are the only meta position, you may show it, that's the reason I have written commonly to identify ortho para meta, that means adjacent, alternate and diagonal or end to end. Okay, just remember these hints. Otherwise, don't focus on those positions where I am putting the, anyway there are 6 carbons only. So, these are the only 3 possible ways we can have disubstituted compounds. Okay, so over here it is now meta-dibromobenzene, or we can say 1,3 dibromobenzene. Okay. Now, few more other examples I would like to take for aromatic compounds. Let's say if I have a system where methyl group is at 1 and at para position we have chlorine. Okay, so basically we call this as, suppose if there is no chlorine, we call this as toluene, correct? This is actually toluene, that is methyl benzene, we commonly call it as toluene. But now chlorine is introduced to this toluene system. Okay, so how can we write this as para chlorotoluene? This is commonly called nomenclature, but otherwise we can have 1 chloro, alphabetically C letter comes first, so 1 chloro, 4 methyl benzene, 4 methyl benzene. All right, now furthermore let us know if we have, there are 3 different positions where bromine is bonded to aromatic system, then it is 1,3,5 tribromobenzene. And the next one, I should not write, okay, I won't write, it is not visible, okay, I'll write there, I will rewrite this one. See the compound that I drew, I am redrawing here, so you can see there are 3 bromines. Okay, then it is 1,3,5 tribromobenzene. Okay, hope it is clear now. Now few more system we can have. This last one, I mean we have already seen this. See, this one is called as benzyl chloride. All right, but then if there is a system where there are 3 carbons, you can see this one, then what will be the name? Here carbon number 2 is, this is actually methyl propyl group, and that propyl carbon number 1 is taken by this aromatic ring and carbon number 2 is taken by chloro. Alphabetically chloro comes first, so it is 2 chloro 1 phenyl propane, 1 phenyl propane. Clear? Yes? Okay, and this one is, I have already given you the name for this, that is benzyl chloride. Hope it is clear to you now. And if there are suppose 2 carbons, in that case let's say if there are CH2, Cl, then this one will be 1 this is actually, suppose if there is no chlorine, what will you call it as? Ethyl benzene. Okay, but because there is chlorine and this chlorine is having the substituent and also phenyl ring as a substituent, so it will be 1 chloro 2 phenyl ethane, 2 phenyl ethane. Okay, clear? Okay, so this is all about nomenclature. Till the time I rub the board, relax, cool down. We will go to now isomerism. Okay, hope this is clear now. I hope you are simultaneously noting down, right? Okay, all right. Not to rub this part. Okay, okay. Any doubt? What you want me to repeat? Okay. See now, let me tell you. Ortho is ortho, meta. These prefixes are used for common names. Numbering, you do one thing. You better fix in your brain writing the nomenclature using number system only. Okay, that means writing the nomenclature by using this number system even for aromatic compounds. Okay, so better leave out that confusion of when to write this ortho meta para and okay, okay, see, why not? Okay, see, because this one is ortho meta para is applicable for di substituted. No, that is applicable for di substituted compounds. Okay, but here there are 3 bromines, so you cannot introduce those meta comma meta. No, you cannot write. So better you focus on writing the nomenclature using number only. Okay, yes. Now we will focus on nomenclature is done, but isomerism, which you have already studied in your 11th standard about isomerism. But in case of halogen compound, halogen derivatives, let us know what is that different thing we will know in isomerism. So basically, what is isomer, by the way? Yes. Correct. Yes. Isomers are the one which have same molecular formula but different structural arrangement, different structural formula. Correct. That's right. So, let us understand this isomerism. Okay, in haloalkanes and haloarenes. So, the first type, that is about chain isomerism. Now, in this chain isomerism, basically there will be the carbon chain. Okay, but if the carbon chain is having the different arrangement of the carbons in it, like for example, I know that this is the straight chain where the bromine is attached, or there is also, and there are 4 carbons, and there is also possibility that these 4 carbons would be arranged in this way, or these 4 carbons can be arranged in this way. Yes, this is one way to write down, right? So, these are the 4 different ways the way carbons are arranged. That is why it is chain isomer. Okay, if the carbon arrangement is varying, then that is chain isomer. Okay, focus on carbon arrangement. If the carbon arrangement, that means here in the first case it is N. Okay, why N prefix will come? Because it is a straight chain, and this one is actually, we can see the bromine is in a straight chain, but provided the carbon chain where it was N system, but it is not N, but rather it is isobutyl. This is isobutyl, and this one was tertiary butyl. Okay, so this is N-butyl, this is isobutyl, and this is tertiary butyl. Okay, so this was the difference where the carbon arrangement was varying, and that's why the name chain isomerism. Okay, now coming to position isomerism. Okay, so in case of position isomer, carbon length will be same. Okay, but here the end carbon is having iodine, and whereas here middle carbon is having iodine. Okay, so in this case the substituent, the entity that is bonded, the functional group position is varying. That is why the position of the functional group is changing. So that's why this one is positional isomer or position isomerism. Okay, so this is how. So this one is like 1 iodo-propane. Okay, and or simply you can call it as iodopropane, and this one 2 iodopropane. 2 iodopropane. All right, clear? Now the next one could be isomerism type would be So these are enough. Okay, so these two are enough for you to understand the isomerism, that is chain isomerism and position isomerism. So position, again I am telling you, the position of the functional group is varying, and in case of chain it is carbon position, arrangement of the carbon is varying. Okay, so we have done with the isomerism as well. Now coming to exhausted. Oh no, 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 you should increase your stamina. See, you people are in grade 12. Huh? How, larger length of study span you should have. See, this tells you about your, consistency or, persistent efforts. Meaning, when you are actually engrossed in understanding a particular concept, then I don't think you should feel bored. Why should you? Is it not that only one way it is going on? See, I am asking you also, you people also interacting, you people also raising up your doubts. So it is going two way, right? Okay, okay, that is the case. Okay, we will wait here, no problem. But I hope you have noted down all these things. Huh? I hope each and every board work is jotted down. Okay. Wait, not to log out. Perhaps I might give you few compounds for the nomenclature as a homework. Wait. Well, you can take these as an examples for nomenclature. Write IUPAC name for these compounds. Can you tell me what is the type of formula that I am representing this one? Yes, tell me. Type of formula. It is condensed formula. Condensed formula. You don't show any bonds. Please do this homework at home. And these are to write down the IUPAC name, and some of the names I would give you, and you are going to draw the structures. You have to draw the structures. 2-bromo-2-methylbutane, 1,4-dichloro, 1,4-dichloro 2-methylbenzene, now take this one, a bit different one, 1-bromo 4, 1-bromo ethyl, this is in bracket, okay, 3-chloro 2,27 trimethyl-octane. I'm continuing the name here, okay, trichloro-octane, right, trimethyl-octane, trimethyl. Yes. Try out these examples at home. Okay. Thank you all. Have a good day. Once again, happy Dashera.